Hello, everyone. I have a great pleasure today to run our five questions session from our five questions series with Jo Prichard. I've known Joe for almost 2 decades now. He's one of our senior data scientists in LexisNexis Risk Solutions, and he's been involved with data science and HPCC systems for a very, very long time, since the inception of HPCC, pretty much. He is, as I mentioned before, a data scientist, and it is a rare occasion where we can interview a data scientist, true data scientist, in this series. So I am really, really pleased that we could get some time from him, his busy schedule, to be here. I don't want to do much more preamble here. I think he has plenty of interesting things to cover, and I am sure you will enjoy this session. So hello, Joe, and welcome.
Hey, Flavio. Thanks for having me.
Joe, it's great to have you here, really. And the first thing that comes to mind is certainly the question around your decision to get into data science. I know that you've been a computer scientist for a long time, and you have some soft spot for data science. You've been always doing something that was data science related, even before data science was called data science. So what really makes you believe that this is your real passion in life? Why do you like data science so much?
So so as you were saying, I have my background is predominantly in computer science, and specifically in software engineering. And what happened with my career is that at key points I've met interesting people. And along the way, I was both introduced to a really phenomenal team that taught me more about just computer programming than I realized, but also introduced me to the world of wrangling big data for all sorts of purposes. And that's where I really felt like it was a tipping point for me. Was originally I did a lot of work in the visualizing graphs realm, and we used it predominantly for visualizing networks of things that revolved around public records. So people, addresses, vehicles, properties, all sorts of things. And what happened was that there was a natural transition of that to being able to do graph analysis, where we want to unravel or measure networks of connected things, and specifically to figure out where to look in a big graph where fraud might be occurring or some anomalous behavior. And what really was the tipping point for me was when I realized that HPCC was a really good way to boil the ocean, and I watched David Bayless solve some very complex challenges with a ton of data and generally a ridiculously small amount of code. And watching him work and learning from him about how he thinks about problems from a data and technology perspective, that really it's an exciting thing to do, because you effectively learn how to be like a large-scale data detective, where you can build things, measure things, and really look at your data from the perspective of what does this tell me about the world around it. So I found that terrifically exciting. I mean, anybody who's watched a crime show where people use, like you see the stuff on TV, it looks all exciting, and within 2 seconds they've pulled up somebody's DMV record. That never happens in the real world. That's not how it works. We have rules, and but the underlying premise is right, is that if you have data and you can measure something, you can tackle some really complex problems, it's like solving puzzles with data. It's very exciting.
Yeah, of course, it's never as sexy as you see in TV, right? Hollywood is Hollywood, but
yeah, exactly.
But life sometimes is different, yes. But tell me a little bit about what you actually do. What is that you do in data science? I don't know if you can disclose much, but what do you do for LexisNexis? what does LexisNexis Risk Solutions do in like data science, and how do these social graphs really develop into something that is useful for the company?
So I mean, we have a lot of different verticals, and we leverage the technology in different ways in different verticals. From a social network point of view, or from a graph perspective, the use cases might be different. The domain of data might be different, but a lot of the same types of behavioral networks are kind of set up to really target a system in a specific way to either commit fraud or to do something that somebody shouldn't be doing or a group of people shouldn't be doing. And what we do is we use graph analysis to measure everything that's happening within a large network of connected things to understand where we should be paying attention to. So like property networks, like flipping networks is a good example. It's not illegal to flip a property. So you can flip properties, there's shows on TV. There's a fine line between flipping properties for profit and fraudulently flipping properties for profit. So what we want to understand is how are the networks of people operating, and was this, at a transaction level, how do we leverage graph analysis? The kind of thing that you'd want to know is, given there's a transaction between Flavio and Jo, is there potentially a relationship between Flavio and Jo? So that's very easy to do. Well, it's not easy to do, but it's a very easy thing to understand, where that's a very simple example where you overlay the relationship graph that you have coming from public records or from other places. You overlay that with your transaction on either side to see, is there potentially a relationship between the buyer and seller? And if there is, it doesn't mean it's fraud, but it does introduce a level of risk. So that's just an attribute that we have right there. Now, where it gets really interesting is if I flip a property to Flavio, and Flavio is potentially an associate of mine, that's a higher risk transaction. Where it gets organized is interesting, because you can say, oh, hey, is there a network around Flavio and Jo that have done this more than like just this one time? Is that a systemic thing in that part of the graph? And then you compute attributes about that. So now you're not only looking at, is Jo flipping a property to a known associate, but you can also say, oh, this is the 5th time this has happened within their network, their local community of connections, and that increases the risk even more. So what we do is we compute everything in the graph, and that gives you, it flattens out the graph, so you have all these attributes that tell you more about what's happening around that particular point. And that's where HPCC is phenomenal. It allows you to like pull in tons and tons of data and just compute that all in one go. And obviously we have a language that helps do that seamlessly, which doesn't hurt. But when you go and stare down into what's happening underneath the covers, it often will span out to like 30 trillion rows later without you realizing, because you only wrote like less than a page worth of code to do that. So that's really where the power comes in. It's very interesting, because it's really on how you think about using graphs to tackle a particular business problem. So it could be property network, nefarious property network examples that you come after. It could be prescription drugs. It can be insurance fraud, like where people are staging accidents. They all have a similar sort of dynamic to them, and we measure them in very much the same way.
That is very, very interesting. But I'm sure this is not the most interesting case that you've been working on. So I don't know, I think you mentioned crime scenes. So is there anything in that area? I do like some of those shows on TV. So have you worked on something exciting like that, and helping solve a crime, or maybe deal with a cold case?
So it's interesting, because we have so much data that we curate, and we take it very seriously. And so there are a couple of perspectives that we think we have a duty to do certain things. So, for example, the one would be from a privacy perspective, we take the curation of our data seriously, and what we care about is where people might be misusing or abusing identity. So from a risk analytics perspective, as a company, we make money off doing identity solutions and things like that, which is awesome. But underneath the covers, we also care about working on analytics and features that will help identify which consumers potentially are having their identities stolen or misused or abused. And so we're very careful about how we tackle these things. We are continuously trying to work towards improving what we produce so that we can build in some processes that will actually help protect the consumer more, right? So there's that. But then on the flip side, we also have this responsibility where we realize that because we have so much data, we should be using it for good. So we have an initiative that we call, I think we call it We Cares, which is like a play on RE Cares. And what we do is we do pro bono work for law enforcement from time to time, and we predominantly at the moment focus on missing and exploited kids. So it's missing and exploited children, where we want to try and help NCMEC track down where an abducted child might be, or where the abductor might be taking them. So we look at that. Some cases we'll try and triangulate where the person who's abducted the child's footprint lies and their social network lies, so that we can map out the most likely direction or area that they might go to and where resources might be assigned. So there are things like that. The thing that excited me most about coming to LexisNexis and using the data for law enforcement purposes in ways that people just couldn't imagine was originally David Bayless. Watching him wrangle data, like he literally wraps his hand around all the data, and he was computing results to try and help law enforcement understand which people might have been in an area related to a sequence of serial crimes. And that can be arson, it could be a serial killer, it could be a serial rapist. And he did an original example, Troy Graves, and he's done a couple since as well. And that was amazing to see, because I swear it took him less than 20 minutes. In our header, maybe we have like for the data he was working with at the time. And remember this is back in like 2002, and there he was wrangling like 30 billion rows of data like it was nothing. And he gave them a list of maybe 40 people, and they were investigating, and they were back, and I think he was like number 8 or 9 on the list. And that just blew my mind, is that you could take that amount of data and pull out a needle in the haystack with less than maybe a page of ECL code. Just absolutely amazed me. So the thing that I've learned most from David is really how to think about solving these problems. So if you have a problem, so one of the, like to give an example, one of the initiatives that we think we can help with is to help solve Jane and John Doe cases. And with that, the idea is they have somebody, they don't know who the deceased individual is, and they'd really like to bring closure to some family somewhere. Can we actually triangulate a short list of people that it might be, identities that it might be, to help them close that case? And we think that's something we should be able to help with, or at least give some indication would be nice. So that's the type of challenge that we really do pro bono for various groups, to try and provide value from the data that we curate, because it's something we think is important. So for a good example, that's a great example, because most of the work is not coding work. Most of the work is thinking work. And it's a great chance to, I often run through these with various people, because it's a great chance to kind of brainstorm through it, but also to teach younger people just how to, various ways of thinking about a particular business problem, data and technology to solve that.
That is very interesting. Yeah, well, of course, it's sad, but it's very interesting that we can do that and perhaps help bring closure to some of these cold cases.
Yeah.
So let's change topic a little bit just to get this closer to HPC systems. So certainly there are plenty of data science platforms out there. Certainly there are graph databases and there are other analytical tools. Why HPCC? So I know that you've been working with HPC systems for a very long time, but what does it bring that is difficult or hard to get from the other ones that are out there?
I think, certainly from my perspective, and this has been the case for a while, is that the platform was built very much with efficiency and simplicity in mind. If you look at how easy it is to bring up either one node or a multi-node, pump a bunch of data into it and start doing stuff, it's actually ridiculously easy. But the core platform itself, has very few moving parts. I think the very few moving parts scenario is important because it's like an electric car. There's less stuff to go wrong, there's less stuff to maintain, and allows you your resources can be more focused on actually doing stuff. And that's really important when you're running a company. You need your platform to be efficient. You need your platform to be robust and consistent in terms of producing content and value so that you can drive your products, you can generate revenue and hopefully profit. So I think the initial thing that's important is for people to understand that value. It'll lower your resource cost in terms of person resources because you don't need as many people coding furiously in, say, Java to code up a ton of stuff. You're writing a significantly less code because you have effectively a higher level language that sits on top of all of the C++ that it's generating. So
that makes perfect sense.
Missed,
Yeah.
you know what I mean? Like that's often missed because of the simplicity of that. At LexisNexis, we're very used to the fact that just exists. Most of the people who have been working in ECL for a long time have no idea how complicated it could get if they were using some of the other technologies. And those are moving at the same time. Those have grown over the years, so they're becoming more simple, I guess, to implement. However, it's a balance between how much stuff do you want to take on, how complicated do you want your stack to look like. And I think it's interesting now that we've actually reached that tipping point where HPCC itself is looking at, okay, which of these do we think are worthy of putting into our stack or integrating into our stack. I think that's very exciting.
Yeah, and it makes perfect sense. I guess the example of the car is you don't want to go and buy one engine and a few wheels and some tires and some bolts and nuts and put it together yourself. You just want to get the car to drive it and make the best use of your time, right? I think that's absolutely that makes sense. So, but just changing topics one more time, and I want to close this with a little bit of something that is different from the rest of the 5 question sessions. In this case, I know that you've been a mentor for the HPC Systems internship program several times, and including last year. And I'd like to ask you, what was your experience last year in particular in the internship? Tell us a little bit about who you mentored and what got done and what the overall experience for the mentee was for that internship.
So last year I mentored Nicole Navarro, and what was interesting about that was it was the first time I'd mentored somebody specifically from a data science perspective, and it does fit into our it fits into my whole mission of wanting to train a younger generation to take over. And the first thing that I'd had to do was to really look at how do we get get the intern up and running so that within the relatively short amount of time, they can do something that's both engaging and meaningful without being dragged into, like, say, 9 weeks of grunt work and then one week of actual work that is fulfilling. And unfortunately, data science typically is 90% grunt work and 10% glory, or even less. And so what we have is, fortunately, we have some really neat tools that we've built on top of HPCC, and that allowed us to actually massively accelerate Nicole's path into getting to the point where she could really focus on doing the work that she needed to do for the internship, but where it's also fulfilling in the sense that you get feedback and you can actually immerse yourself. So I really wanted to immerse her in the problem that she was focusing on, and also have all the data at her fingertips. And our tools really helped on that front. But we also wrapped a bit of like a larger team around her to fill in different gaps at different points. So she wasn't trying to do it all on her own. It wasn't a case of like, here's a ton of data, go figure it out. It was, here's a ton of data plus a support group plus supporting tools, and we'll help you get to the points so that you learn as much as you need to without being dragged down by all of the grunt work. And then it allowed her to really get into focus on the specific perspective that she was focusing on. So Nicole was focusing on looking at geographic, specifically for the opioid epidemic, she was looking at areas in a specific part of the country where the communities where those prescription drugs, or where the prescriptions were going to, were had higher concentrations of more connected social networks. And can we tell where those areas are? Number one, like, can we identify the dense areas so that we think those are areas that are potentially receptive to intervention programs, like community-based intervention programs. So what was nice is that we actually had the tools and support to get her to that point really quickly so she could focus on the part that she wanted to do. But it also gave her the ability to visualize and measure things all around that so she could grow her understanding. And I think having a framework to do that's really important. If that had happened maybe 2-3 years ago, we wouldn't have had all the things in place to be able to do that. But I think it allowed us to do a better job of mentoring her for that purpose, which I thought was really good.
That is an amazing story. Yeah, that's very good. So, Jo, unfortunately, we're running out of time. So I just want to thank you very much for this interview. I think it's been very, very good, very enlightening. And it was, again, great to get in touch with you again. So thank you very much. And everyone else, thank you for listening. I hope you enjoyed this as much as I did.
Thanks,
Bye.
Flavio.